I want to begin with a confession. I have spent a great portion of my life thinking about things that may not exist. Black holes before we confirmed them, nuclear-powered starships that we never built, and civilizations out among the stars that have so far declined to introduce themselves. This does not embarrass me in the slightest. I think the greatest questions a mind can entertain are precisely the ones where we do not yet know the answer. And the question I want to talk with you about today is, in my view, the greatest of them all. Where is everybody? That is the question. 4 words, and yet they contain within them all the loneliness and all the wonder of our situation as a species. That question was first posed, at least in the form we now recognize, by my old colleague Enrico Fermi over lunch in Los Alamos in the summer of 1950. They were talking, he and his friends, about flying saucers and the probability of intelligent life in the galaxy, and Fermi, with the legendary swiftness of his mind, jumped several steps ahead of the conversation and asked quite simply, if there are so many of them out there, where are they? Why haven't we seen them? Why haven't we heard them? He didn't publish anything about it. He died 4 years later. But that question has haunted every serious thinker in astronomy and physics ever since, and I consider myself very much among the haunted. Now, I want to be careful here at the beginning, because there is a way of framing this problem that sounds overly dramatic. The universe is 13 billion years old. It contains 2 trillion galaxies, each with hundreds of billions of stars, and yet here we sit in silence. Is that not damning evidence that we are alone? Well, perhaps. But I would counsel against reaching for that conclusion too quickly. What I want to show you today is that there is a physical trap built into the very fabric of the universe, a constraint so fundamental, so elegant, and so severe, that it may explain the silence more simply than any theory about the rarity of life or the self-destruction of civilizations. That trap has a name we all know. It is the speed of light. Let me walk you through the mathematics, not in a way that will frighten you, but in a way that should astonish you. Our galaxy, the Milky Way, is approximately 100,000 light-years across. That number is worth sitting with. If you could travel at the speed of light, which you cannot, as I will explain momentarily, it would still take you 100,000 years to cross from one edge of our galaxy to the other. Our nearest stellar neighbor, Proxima Centauri, is 4.2 light-years away. A signal sent to Proxima Centauri today would arrive in 4 years and 2 months. A reply would take another 4 years and 2 months. So a simple exchange of greetings, hello, we are here, and the response, yes, we hear you, would take nearly a decade. And that is with our nearest neighbor. Now suppose there is a civilization orbiting a star in the middle of the galaxy some 50,000 light-years from here. A message to them would take 50,000 years. Their reply, another 50,000. The entire exchange would span 100,000 years, roughly the duration of Homo sapiens as a species on this planet. To communicate meaningfully with such a civilization, you would need an institution with a patience that no human organization has ever demonstrated. You would need something that thinks in geological time. This is what I call the light speed trap. It is not merely an engineering problem, it is a structural feature of the universe. Einstein was very clear about this, and unlike many things in physics, this particular result has proven extraordinarily durable. Nothing with mass can travel at the speed of light. Energy requirements become infinite as you approach it. The universe has rather brilliantly imposed a cosmic speed limit, and that speed limit imposes in turn a kind of quarantine between civilizations. But let us step back and ask the deeper question. Given this trap, what should we actually expect to see in a galaxy full of intelligent life? I have thought about this for many years, and I find the answer genuinely surprising. We should expect to see very little. Here is why. Imagine a civilization that arose around a star 5 billion years older than our Sun. 5 billion years is a staggering head start. Our entire planet did not exist 5 billion years ago. In 5 billion years, a sufficiently advanced civilization could, in principle, colonize the entire galaxy if interstellar travel at even 1% of the speed of light were feasible. At 1% of light speed, you cross the galaxy in 10 million years. 10 million years sounds long, but it is a mere 1/10 of 1% of the galaxy's age. A civilization with that modest capability and that much time could have been everywhere in the galaxy before our Sun had even formed. And yet here we are, no visitors, no signals we can confirm, no alien engineering visible in the sky. The galaxy appears to our instruments to be rather quiet. So what do we conclude? I want to offer you several possibilities, and I want to be honest with you that I do not know which is correct. I suspect, in fact, that several of them may be operating simultaneously. The first possibility is that interstellar travel is simply not feasible, even for a civilization far older and wiser than ours. I have actually spent considerable time thinking about spacecraft propulsion. I was involved in a project called Orion in my younger days, which proposed driving a spacecraft with a series of nuclear explosions, and I can tell you that even with the most optimistic assumptions, sending a crewed spacecraft to the nearest star would require an amount of energy that strains the imagination. To send something the size of a modest ship to Proxima Centauri in 50 years would require roughly the energy equivalent of 1,000 years of the entire Earth's current power consumption. That is not impossible, but it is enormously difficult, and that is for the nearest star. The galaxy contains 400 billion stars. To colonize them all, even with self-replicating robotic probes, would be an enterprise of extraordinary complexity and duration. The second possibility is one I find quite intellectually interesting, and it connects directly to the light-speed trap I described. Perhaps advanced civilizations do exist in great numbers, but they have no particular interest in communicating with us across such distances because they understand far better than we do that the conversation is not really possible. Think about it from their perspective. If you know that any message you send will take thousands of years to receive a reply, why would you bother? The civilization you messaged might be extinct by the time your signal arrives, or transformed beyond recognition. The very concept of dialogue breaks down across interstellar distances. A civilization that has existed for 1,000,000 years has had time to think carefully about this, and they may have concluded that there is simply no point. This is a different kind of silence from loneliness. It is the silence of rational beings who understand the geometry of their situation. The third possibility is the one that bears my name, or rather the name of a structure I proposed in 1959. I suggested that any civilization sufficiently advanced would, almost as a matter of thermodynamic necessity, expand its energy consumption until it had captured all of the energy emitted by its star. The mechanism I proposed, now called a Dyson sphere, though I actually envisaged a swarm rather than a rigid shell, would completely enclose a star in a shell of material, converting all its light into useful energy and radiating the waste heat as infrared radiation. Such a structure would be visible. It would appear in the sky not as a bright star, but as a dark, warm object glowing in the infrared. We have searched for such objects. We have found some intriguing candidates, most notably a star called KIC 84628552, which some people call Tabby's star, whose brightness varied in ways that were initially puzzling, but nothing confirmed. Nothing that we can say with confidence is the artifact of another mind. And yet I want to be careful not to present this absence as proof. We have not searched very long. We have not searched very thoroughly. Our telescopes, though remarkable, have only been turned toward this question seriously for about 60 years. 60 years is nothing. It is a heartbeat in astronomical time. The fourth possibility I want to explore is perhaps the strangest, and it is one that has been discussed seriously by physicists who are not easily given to speculation. This is the idea that the light-speed trap operates not just as a practical barrier, but as an evolutionary one. Civilizations that develop interstellar ambitions quickly discover that the universe does not reward haste. They cannot move fast enough to maintain empire. They cannot communicate fast enough to maintain coordination. And so perhaps they do not try. They turn inward. They build extraordinarily rich and complex civilizations within the confines of their own solar systems. They have no need to expand because the resources of a single star, properly managed, can sustain an unimaginably large and sophisticated civilization for billions of years. I find this possibility rather beautiful, actually. It suggests that the silence is not the silence of emptiness, but the silence of sufficiency. They are not out here looking for us because they have everything they need where they are. Now, you might ask me, and it is a fair question, Freeman, you said the light-speed trap prevents contact. But what about radio signals? We have been broadcasting radio waves since the early 20th century. Those signals have now expanded outward in a bubble roughly 100 light-years in diameter. Within that bubble, any civilization with a sufficiently sensitive radio telescope could in principle detect our presence. We have also deliberately sent signals, most famously the Arecibo message in 1974, directed toward a globular cluster 25,000 light-years away, which means any reply would arrive in 50,000 years, and only if someone was listening at precisely the right moment. And in the other direction, we have been listening with SETI, the search for extraterrestrial intelligence, for more than 60 years, scanning millions of frequencies, and we have detected nothing unambiguous. One signal in 1977, the WOW signal, caused great excitement. It had the characteristics one might expect from an extraterrestrial transmission, but it was never repeated, never confirmed, and remains to this day unexplained. The silence of SETI is not nothing, it is data. It tells us something, though we argue about exactly what. My own view is that it tells us either that radio communication is not how advanced civilizations communicate, they may have moved on to methods we haven't thought of yet, or that they are not trying to communicate at all for the reasons I described. There is also the sobering possibility that civilizations are simply very rare, that the emergence of life and then of intelligence is far more unlikely than our optimistic equations suggest. I am not fond of that explanation, but I cannot rule it out. Let me now talk about something that I think is underappreciated in these discussions, which is the problem of time. We tend to think of the search for extraterrestrial intelligence as a problem of space. Are they out there? But it is equally a problem of time. Our civilization has been capable of radio communication for about 100 years, 100 years out of a universe that is 13 billion years old. If intelligent civilizations are common but short-lived, lasting, say, a few thousand years before extinction or transformation, then the chance of two civilizations being active at the same time, close enough in space to communicate, is extraordinarily small. The light-speed trap exacerbates this enormously. Even if a civilization was broadcasting 10,000 years ago, their signals may have already washed over us before we had the ears to hear them. We may have missed the transmission entirely. There is a concept in physics called the light cone, the region of space-time that can in principle be causally connected to a given event. Your light cone extends outward at the speed of light in all directions, forward in time. The intersection of two light cones, two civilizations that can reach each other, is not guaranteed. In a universe where civilizations blink in and out of existence over cosmic time, the chances of overlap may be quite small, regardless of how many civilizations have existed or will exist. I want to say something now that I consider important and that I think is often missing from these discussions. The silence should not make us despondent. It should make us humble, and it should make us curious. We are, as far as we can tell, a young species on a young planet, asking questions that our instruments are only barely capable of addressing. We have been listening for 60 years. The galaxy is 10 billion years old. We are in the first seconds of a search that may take millennia. The fact that we have not yet found an answer is entirely consistent with the answer being there, waiting for us to develop the right tools, the right patience, and perhaps the right wisdom. I have always believed, and this is a view I have held since I was a very young physicist, that the universe is not hostile to mind. It is not designed for us, but it is not designed against us either. The laws of physics, which are the same everywhere in the observable universe, are laws under which intelligence can arise and survive and flourish. That we arose at all is remarkable. That we can ask these questions is more remarkable still. The light-speed trap is real. It is severe. It imposes genuine hard limits on what any civilization, ours or theirs, can do to reach across the void. But limits are not the same as impossibilities. We sent men to the moon not because it was easy, but because the difficulty itself was instructive. If we ever do establish contact with another civilization, it will not be through a casual exchange of messages. It will be through the sustained, patient effort of many generations, operating across timescales that no individual will live to see completed. That is humbling, but I do not think it is discouraging. It is simply the scale on which the universe operates, and we are learning slowly to think on that scale. I want to close with a thought that I find both sobering and strangely comforting. In the long history of this galaxy, if civilizations arise and grow and then fall silent, whether through destruction or transformation or the simple decision to look inward, then we right now, in this particular moment of broadcast and signal and listening, are a civilization in its most communicative phase. We are shouting into the dark. We have been shouting for 100 years. For all we know, there are others who shouted before us and have since gone quiet, and there are others who will shout after us when we, too, have either perished or grown beyond the need to call out. The universe is very large and very old, and the speed of light is very, very slow by comparison. That is the trap, that is the silence, and that, I think, is the most profound fact in all of science. We are here, we are asking, and the stars for now are not answering. But I have spent my entire career betting that the universe is more interesting than it appears, and I do not intend to stop now. Thank you